Hello. First of all, we would like to thank everyone from taking their time off to attend our virtual event. My name is James Lai, and I'm the Managing Director for Jytek Southeast Asia. Today, we're going to talk about data acquisition and IoT, right? And this is our agenda. First, I'll go over who we are, who is Jytek, and what do we do. We're going to look at data acquisition fundamentals and also how DAQ or data acquisition fits into the IoT value chain. Later on, my colleague will going to talk about hardware platforms, and he will actually do some demos to show you how to use our software, and also look at the different software platforms, especially C#. And we're going to look at some application development examples, and if we have time, we're going to go through some question and answers from the audience. So Jytek is a pretty new test and measurement company. Basically, the company came about with collaboration with AD-Link. So it's a joint venture company with AD-Link, who is a well-known data acquisition and test and measurement vendor, whose HQ is based in Taipei. Eventually, AD-Link will spin off its test and measurement business, and it will become Jytek, and consists of PXI, modular instruments, data acquisition, and GPIB. AD-Link is one of Intel's top 4 vendors globally, and has been in the business for quite a while. What Jytek will bring into the table is we will provide our software platform called Jytek SeeSharp, which gonna focus on later on, and we provide complete coverage under existing AD-Link PXI hardware platform. And we also have partnership with well-known PXI vendors such as InnoWireless, Pickering, and Keysight. We have a direct sales model, and we will try to set up direct offices across the region to service our customers. And we serve a broad base of customers, ranging from semiconductor, electronics, to military, aerospace, to research and academia, and so forth. And we also have a resources to support our customers in using both our hardware and software platform. So we have actually branches in all these countries. For the ASEAN region, the headquarters is actually based in Jytek, Malaysia, which I'm heading. Data acquisition fundamentals, or DAQ for short. Basically, a data acquisition system consists of sensors, right, that measures temperature, strain, force, and the sensor is connected to a DAQ device that provides signal conditioning for the signal and analog digital converter. And this hardware connects over a bus to a computer system. Could be a laptop or PC. Uh, and we provide driver software to control our hardware, and our customers can use all these components to come up with their own customized solution or application software. Let's look at the sensor. So basically, a sensor or transducer converts physical phenomena such as temperature, strain, force, vibration, and sound into an electrical signal in the form of voltage, current, right, or resistance. In a nutshell, there are two types of analog signal from the real world. You have the digital signal. In this case, you're interested whether the signal is on or off, 0 or 1, high or low. The other type of digital signal is that you are not only interested in the state of the signal or the state of the signal, but also the rate of change of the state. That means you are interested in how long the signal is high and how long the signal is low, and you can use it to do pulse measurement generation. In some cases, if you're a sensor that can detect speed or position, you can use the signal to measure the rate of change signal to measure the speed or the position of the signal of or the object, right? In this case, from the illustration, you can see that based on you have a certain disk that spins around, and depending on where the point touches, you actually to know what is the rotation speed position, or also the direction of the rotation, whether it's clockwise or counterclockwise. Another type of signal that is prevalent and is the analog signal. Analog signals are basically continuous values that changes over time. Example of such a signal is could be coming from a temperature sensor that will measure electrical signal that changes over time. It could be sound coming from a microphone sensor or transducer, or vibration signals coming from an accelerometer. Basically, you have two types of uh, DAQ families offered by Jytek. You have a general data acquisition that is typically used to measure voltage and current coming up from the signal. It has typical resolution from 12-bit to 16-bit. And in most cases, if you're going to connect a sensor to this general DAQ, you need to provide your own amplifier or signal conditioner that amplifies and provide excitation to your signal before it can generate the signal back to your data acquisition. In some cases, if you are looking at measuring dynamic signals, signals that changes over time very quickly, and you have noise embedded to the signal, we have another type of data acquisition, which is called the dynamic signal acquisition hardware, right? Similar to the general DAQ, it has A to D. However, the A to D tends to have at least 18-bit or 24-bit resolution. You could actually have AC or DC coupling to remove the offset through the hardware, and it comes with built-in signal conditioning or excitation. For example, we have dynamic signal acquisition hardware that is well suited for IEPE or ICPE sensors, where the amplifier is not needed, and this simplifies the connectivity of your system. The other parameter or specification that you need to look at is the resolution of the A to D converter or ADC of your data acquisition card. In an actual scenario, let's say this is your original signal, right? Before you can convert this original signal to a digital domain, you need to go through the A to D converter. Again, this is showing A to D converter resolution with 3-bit resolution. It means that it can actually differentiate this analog signal into 8 parts to the power of 3. If I have a 8-bit resolution A to D, then you have even more levels to differentiate the signal with. In a nutshell, a data acquisition device with higher resolution provides you the accuracy and sensitivity to measure more smaller signals, right? The other parameter you need to look at is the dynamic range. The concepts of dynamic range and signal to noise ratio are pretty closely related. Dynamic range is the ratio between the largest valid signal that you want to measure or digital number and the smallest viable one, right? So how much dynamics range do you need for your application? Well, it depends. If you are measuring data from, let's say, a temperature sensor, and the smallest value you need to measure is 0.1 degree, and the largest value you want to measure is 100 degree. If you do the calculation as stated in the formula, you'll arrive at a value about 60 dB, or you need a to D with at least 10 bits. However, if let's say you need to measure the temperature, smallest temperature to 0.01 degree, up to 100 degree, then you probably need to have a to D resolution of 13 bits or more, right? The higher the resolution of the DAQ device, the higher cost you have to pay for it. Signal to noise ratio is the ratio of the desired signal size to the noise signal size, right, or the noise floor. So you need to select a data acquisition device that has a good enough signal noise ratio such that the smallest signal that you are interested in, right, is above the noise floor. If you're looking at measuring microvolts and also volts in the same scenario, right, you need to have a large dynamic range and a good signal to noise ratio to get good results, right? So there are pros and cons. The other specification that you need to look for a data acquisition device is the sampling rate. The sampling rate is the number of samples or points that you want to acquire in your incoming signal, and normally it's stated as number of samples per second, right? So the higher the sampling rate, the more points you will acquire in 1 second, right? So how much sampling rate do you need for your applications? So based on the Nyquist sampling theorem, if you want to correctly reconstruct the frequency domain of your signal, you need to sample at least more than 2 times the highest frequency component of the signal, or we call it the Nyquist sampling, right? So Nyquist frequency. If you don't do sample sufficiently, you come into what I call a anti-aliasing effect, right? So you can see in this illustration, if let's say we undersample the signal, not only you're getting a wrong waveform of the signal, you're getting a waveform that is lower or a false frequency for your particular signal. In practice, we need to sample at least 5 to 10 times the highest frequency component of the signal, right, to properly construct both the frequency and the time domain of the signal. So IoT in a nutshell is a wide uh, area that you need to look at. Basically, you have industrial IoT, okay, and you have IoT or consumer IoT. So industrial IoT or IIoT, again, looking at IoT applications in things such as smart factories, smart transportation, smart cities, smart buildings, and so forth. It's made up of systems and subsystems, and a lot of different type of sensors, hardware, gateway, and so forth. When you talk about IoT or consumer IoT, you are focusing on things like smart speakers, like Alexa, thermostat like Nest, smart watches, and smart devices, smart washing machine, and so forth. So today we're going to focus more on IIoT or industrial IoT. And data acquisition is basically the heart of the whole value chain, right? Because it consists of acquiring, converting physical phenomena from your senses to digital data, and later on you can use that data for big data analytics, right? Analyze the data and use it for machine learning or deep learning or artificial intelligence, right? So it's a pretty much a very important portion of the IoT value chain. When we talk about data, basically the data can not only come from sensors, it could come from RTUs, PLCs, devices, and machines. Again, the data can be coming from also database, from the web, social media, and so forth. So basically, when you look at data collection, you are looking at the 3Vs. Velocity, okay, data velocity means that do you need the data in real time, I mean immediately, near real time, periodically, or batches, right? Variety, so we're talking about data coming from, for example, a sensor, data coming from a camera, a video stream, coming from the web, or coming from a database, right? And then the last thing you need to look at is the volume. So if you have data coming from a sensor like temperature, which doesn't changes much, for example, for smart homes, per day you might be getting kilobytes of data for one channel of temperature or humidity measurements. However, if you're measuring sensor data coming from a microphone or sound, you could be measuring at least megabytes of gigabytes of data and so forth. And you're coming data coming from images, cameras, up to 30 frames of 60 frames per second. You could be dealing with terabytes of data per day, right? So again, these are the three parameters to look at. So how do you ingress data into your application that's running on the cloud? So you need what I call IoT gateways, right? So you can see in the illustration, you have sensors that connects to your DAQ device, right? That is connected to your IoT gateway that can be connected to the cloud, either wired or wirelessly. Okay. Again, you can actually use the data to perform deep learning, right? And use that model to do artificial intelligence. The last part of the value chain is cloud. So where are you going to store the data? Again, it could be stored in a data center, a database, and the type of database you could be using either a structured database, SQL, or NoSQL, unstructured. And in data pertaining to sensors, you're looking at specialized database like a historian or real-time database. Once you have the data ingested in your cloud, you can start to do the analytics for your data. So in terms of where you want to store the data and where is it ingested, again, there's a slight debate here, right? Some companies prefer to have all the data, all the raw data stored into the cloud, right? In some cases, you also have data stored into the gateway or small nodes, they call what it calls fog computing. So depending on application, if the application do not have very fast connectivity like 4G or 5G to the cloud, right? You might need to store on the edge or the gateways before you can ingest to the cloud, right? And then once you have the data residing on either the edge or the cloud, you can have IoT dashboard, right? Running on a browser, on an app to view and collect the data, right? So again, there's analysis trade-off. If you have everything stored in the cloud, then you need to have massive computing power to analyze the data. If you stored some data at the edge, you could analyze some of this data and also return some of the results to the cloud, right? Depending on how fast you need the results, right? All the analysis done. So I'm going to pass the floor to my colleague Vincent. We're going to cover about our software and hardware platform.
Oh, hi everyone. So first and foremost, right, so I would like to thank you for taking some time to joining this webinar. And Vincent Chia is here. So I'm going to start the presentation with some of my self-introduction. So my name is Vincent Chia. So I'm graduated in a bachelor degree of electrical and electrical engineer and diploma of electrical engineer in this local university called UNIMED. And when I first graduated, right, so I joined Plexus on the Teradyne project as a test engineer. And after that, I moved into a National Instrument as an inside sales development engineer. So now, currently, I am in Jytek, working as a field sales engineer, focused on application and support on a datalogger or maybe DAQ platform. Okay. So I will, in this webinar, right, so I will focusing on hardware and software platform with some of the demonstration. So let's say you have any problem, right, you feel free to raise out your comment in the chat box. So we will reply you later on. Okay. So for the hardware platform, right, so we do full cover on hardware and flexible or software, right. So our hardware is including we are including AD-Link, Chroma. We are partnership with those kind of company. So also VI service network spectrum, key site pickling, and control as well. So those hardware that we are covering, including a PSI, data logger, data acquisition system, SMU, high-speed digital I/O, RAID, motion card, RF, AWG, digital multimedia, and bus, such as GPIB bus and other ones, right? So our hardware line is including a low cost, low channel, which is we recommend a USB device. And for the low cost distribute and edge platform, we do have a gateway that have Windows inside, is embedded, right? So for the multi-channel route and edge platform, we do have it also. So for the multi-channel and high performance edge platform, we do offer a PSI platform with also is an embedded system. Okay. So move on our product family, right? So we have a PSI, PSIe, PSI, PCI, PCIe, USB, and GPIB and gateway, as just now I mentioned. Yeah. So you have any problem, right? You feel free to left out your comment. Yeah. Move on. So for the PSI or maybe PSIe, right? So we do offer a chassis 6 to 19 slot. So as you know, right? So they have a PSI associate, right? So our product is based on the associate, and you can use it with another platform, as just now I mentioned, right? You have a Keysight, you have a AD-Link, so it's compatible. Okay. So for the controller, we do offer i3, i5 to i7, and selectable SSD or maybe HDD. Yeah, you can select what you want. So we have a different model on it. Yeah. Move on, we have a TSI platform, and this TSI, as you know, right, is our new product. It supports Thunderbolt, so it's fast and high quality data collection and sampling rate up to 18 mega sample per second, and all channels support signal synchronization, and they have enough of onboard memory where you can store it for longer. Yeah, it's a high performance device that you can get from us. Move on. Also, we have this kind of simultaneous sampling multifunction DAQ analog input from 16-bit 4 to 8 channel, and the speed is 250K until 2 mega sample per second per channel, and the output is 12-bit 2 channel. Also, we have a different kind of DIO 4 to 24 up to TLL and a counter as well. So we have a different model on it, so you can select, or maybe we can advise you based on your requirement. Yeah. So this multi-function that, right, also 12 to 16 bit, 32 to 96 channel, and those analog output DIO. So if you are interested, so I start around maybe for 5 seconds, you can print screen it. So also you have any problem, you feel free to reach out to us, and you can let us your comment, we can contact you. Also, continue with analog output DAQ from 16 to 12 to 16 bit, 4 to 16 channel for the voltage and also current. So up to different kind of spec. So again, we have a different kind of model for it. Yeah, for the digitizer, high speed digitizer, 10 megabyte up to 200 megabytes. And 200 megaseconds, sorry, not byte. Okay, sorry for that. So onboard memory 512 MB to 1 gigabyte. Okay, dynamic signal analyzer for those kind of sound and vibration analysis. And you can see the spec as well. So we do offer a 2 to 8 channel up to, and digital I/O and counter. Okay, and isolated up to 8 to 64. Okay, so next we do have a USB to GPIB or maybe GPIB. So for the USB part, right, no separate power required for using a USB device. So for this USB device, right, we do offer a different kind of model. So those kind of model including analog input output, digital input output, isolated DIO timer as well. So let's say you have any kind of requirement on this. I think for the low channel, right, I think USB is the best part for it. It's the best device for you. So also you can see the counter time 4 to 80 megahertz up to, and also analog output as well. And for this GPIB interface, right, the GBIB interface that we are offering, right, is compatible with NI 488.2, and also is able to support industrial standard visa libraries such as NI, National Instrument, Keysight, and others. So which means you just plug and play without you changing anything. So for example, you have a NI visa, or maybe you have Keysight driver inside it, so you can just plug and play, and you don't need to install alternative things. Yeah, and most importantly is we offer it in the low cost portion. Yeah, so also you can left out a comment, you can contact us after this. For the gateway embedded, we do have a vibration and monitoring edge platform. So 2 to 4 channels simultaneous 1 to 8 kilo sample per second, and it's optional Wi-Fi kit. So you don't have if let's say your site is have a flexible wireless or maybe Wi-Fi, right? So you can use either wireless in a LAN, or maybe you can use a Wi-Fi as well for the gateway module. So also we do offer HDAQ, so flexible. You can plug in just kind of PCI card. Okay, next. Okay, so I will show some of the hardware platform that we have. So before we move to the software portion, so let's check it out. I have a sensor, accelerometer sensor, IMI 603C and 01. Yeah. So in here for the DAQ data logger, so I have a 2405 data sound and vibration module. So you can see here they got 4 analog input channel, AI1, AI2, AI3, and AI4. So let me show you how to connect it. So at the first we have this micro USB. So we plug in into here and we lock it to ensure that it does not plug out. Maybe when we are doing our condition monitoring or anything, yeah. So in the other way, they have a USB port that you connect to your PC. So get back to here, we got our sensor, right? So it's a BNC port that you can directly plug in into our data logger. So you can see in the other way, so you connect with the sensor from analog input, the first channel, and the other way you connect to the USB. So from the USB, right, we connect to our PC. So when we connect it, right, so you can see there's a red light. So you just need to take a minute to wait it, so until it becomes yellow. So when it becomes yellow, which means it's fully been connected. Okay, so once we connect our device with our PC and sensor, right, the first thing we need to do is we need to download the driver, hardware driver. So what normally I will do is I will go to Google Chrome. So let's say you are using a MacBook, so you might be choose a Safari or maybe Internet Explorer based on personal preference, right? So I will grab go to our website, jytek.co. Okay. So first thing, so if you see, we have our product in here, we have a download, event, solution, and support as well. So in here, you can see our product, we have a PSI chassis, PSI controller, digitizer, oscilloscope as well, and also a GBIB interface. So if you have time, you can go through it. So before we start it, right, we need to do a registration in our website. So by default is in the Korean, so you might be translated into English by Google Translate. So first thing, remember to read through the membership terms and conditions. So you can take some time to read through it. So once you agree with that, so you might be click agree. So same to this privacy statement. So you can read through it. So once you go through it, you might be click and agree. So in here, you might be put your ID, password, and password confirmation, and all those details in the registration. So since I already registered it, right, so I'm not going to do it again. So I just click a login. Vincent1205, my ID. So click the password and I click a login. So for the hardware driver side, right, so I will click this download. And from here, right, so you might be search. So for example, we have a 2405 in here. So I will click a search here. So you can see they have a two. So one is the download. I download the latest version one for March 2018 that we have. So I click in, and from here you can see we support various platforms. Linux also have, Windows also have, and Windows 7, 8, and 10 as well. So you can click it, you can download it. So download anyway. So from here, when I go to download here, so I got a driver in here for Windows. So just click download, just click install. Sorry. So take a minute for it to install. So click setup. So preparing to install. So just click next. So I already have the driver, so I'm not going to do it again. So if let's say the driver have some bug or maybe crash, you might be click the modify, or maybe you can repair it. So I'm just going to skip through the step. And actually, how you going to ensure that you have the driver or not? So in here, I will just go to File Explorer. Okay, I will go to my C, and you can check it. So SeeSharp, Jytek, and from the hardware driver, you might click the hardware. SeeSharp, you again C, click a SeeSharp, Jytek, hardware, and from here for our device 6205 is the DSA, dynamic signal acquisition. So I will click the DSA. And Jytek USB, so you can see the driver in here, so which means it's successful been installed. So for the hardware portion, so how we can ensure that our hardware is connected with our PC? So there are two methods. So the first method is go to the device manager, go to Start and Device Manager. So universal serial bus controller, and you can see here you got an AD-Link USB DAQ 245 device. So another side, right? So in here we got a device manager in here, so you can install in our website with the same method as well. So if you have any problem, you can reach out to us as well. So also we can provide you the installer. Okay, so I will just right click it. Device Manager, Jytek version 26, and I'll look for the device. And what we can see is the USB 6205. So slot number 0. So we only have one slot. So let's say you have 2 slots, 3 slots, then the number might be there. So name, so Jytek USB 6205, and you can see the vendor and the model number, and just now the hardware that we installed, the hardware driver here. So you don't have a path. So click on the test panel, and from here we can do some of the demo on it. So the sample mode we set by continuous, so that we can monitor it. The channel number in here we have a channel 0, right? Just now we connected. Sampling rate we put as a 10K. Sample to read we put as 1K. So coupling either DC or maybe AC. So just some of the knowledge, right? So for the AC coupling, right? So it allows the AC signal to pass through the connection. So for the DC coupling, right, so it allows both AC and DC signal to pass through the connection. So what you can see, right? So in here you can see they have a huge difference on it. So with the AC coupling, right, so it's a real data. So basically the signal both AC and DC will be the same. Just if let's say you have a DC, right, you can see the offset number, but for the AC one, it's a purely real result. So what is different about it? So AC coupling, right, so it's mostly focused on IECP microphone or maybe accelerometer. So for the DC coupling is a thermocouple or maybe DC accelerometer. So does not only measure frustration. So what I can say is really depend on what you need. So let's say you have a this ICP microphone, right? You might need to monitor in the AC. So it's not, let's say for thermocouple, you might be need a DC coupling. So actually it depends on your testing requirement. What I can say, yeah. So let us continue back. So in here, I will just use a DC lah. So for the terminal, so they do have two options, either this one or this one. So you can select it. So IEPE, so I'm going to set as true. So I start it. So you can see they have a little bit noise in the initialize. So for the sound, so I have my phone in here, so I will do a vibration so that we can see how it's able to capture. So in here, my phone, I will just use a vibration and I will choose a rapid mode. So for the accelerometer that I have in here, right, so I will just put at here. So let us monitor when I click a rapid, right. So you can see the signal being recorded. So again, I press again. So you can see they have a sound in here. So let me put maybe heartbeat. Okay, another one SOS. Okay, so you can see they have a signal recorder. Again, I put the rapid. Okay, you can see a rapid signal, right? Okay. Okay, so after we have some demonstration on our hardware introduction and device manager, let us move back to the Jytek software platform. And here our platform we call it as a SeeSharp. So the platform is including a C driver, signal analysis library, graphic user interface, and design example. So for the C driver, right, so we do provide a full C driver to all our products. So also up to 90% or above of our product is supported by LabVIEW and other platforms such as MATLAB. So the C driver, it basically is AI, AO, DI, DO, CO, and CI. So for the most basic one lah. So signal analysis library, right? So we do have a GUI for spectrum analysis, phase detection, filtering, harmonic distribution, tone analysis, and including a report generation toolkit, which I will demo it later on. So graphic user interface, right? So you can see here we do have a waveform, we do have a NOS, and we do have a LED on it, digital input. And also we do have a button, the GUI using a open source platform. And for the design example, right, as you can see in here, we do offer those normal design example, continuous AI waveform and a discontinuous finite and all those things. Yeah. So for the sound and vibration toolkit, right? So for the normal one, the filter, FIR, IIR, synchronization, and harmonic, including the RMS, SNR. So for the RMS one, later on I will demo it in the one of example as well. So report generation, signal, white noise, JTFA, spectrum, and frequency response as well. Okay. Let's move on. I will show a little bit of example on the C#. Okay, so just now we demo about the device manager for single measurement. So let's say you are facing a complex engineering problem such as you need to have a few channels measuring together and you need to really customize your test panel or anything. So we do in a Jytek, right? So we do support it. So we have open source test and measurement platform. So let me show you how we can do it. So again, open a browser, go to jytek.co. So again, if you haven't registered, you might be click a register. If you already registered, you might be click a login, my ID, and my password. So this ID is specific for other people. Let's say your ID is not necessarily 1203, or maybe you can have A, B, C, D. So it depends. Yeah, depends on individual. So I will click login. So in here, again, I click download. So in here, they have a SeeSharp software. So click a SeeSharp software. So you can install SeeSharp tools installer and as well as a SeeSharp example. So they have an example for various platforms. So in here, going to install a SeeSharp toolkit. So click and install here. So you have it. Wait a minute. Okay, so in folder. So in here you can see I have a SeeSharp tools installer. So double click it. Click the installer ESD file. Run it anyway. Install. So I already installed it, so I'm not going to repeat again. So I'm just going to close it. Okay. If let's say you haven't installed it, you might be clicking next and install it. Just a very simple within 1 to 2 minutes. So also right, so we have an example in here, recipe 2405. So you can see the analog input, digital output, multifunction. So let's say I click so I can have the AI continuous. So let's say you are a programmer, right? So this might be your good reference. So you can have it, you can combine it. Let's say you want to have an analog input with a digital trigger together. So you might be combine it and create your own program. So it's a good example. So let's say you want to use it directly, also can. And get back to our part, right? So let's say you already installed the SeeSharp tools, right? So how you ensure you install it? So go to here again, SeeSharp, Jytek, and you can see you have this hardware. Just now we mentioned our hardware driver, right? So you can have this SeeSharp tools, and here you can see the menu, SeeSharp tools menu. And we have our SeeSharp tools, we have our EG chart, pressure gauge, and those kind of GUI. So it's a free software, so you can get it for free without paying any kind of charge. No charge required. So they have very audio, DSP fundamental, GUI, and a lot of things you can do with these SeeSharp tools. So let me just simple show. So in here you can see you can have this waveform generator, and also you can have a chart, you can have a log for a measurement. You can have a meter as well, LED, and an EG button, the button that you have, a switch as well, button switch. Yeah, you can get it in the SeeSharp tools. Okay, so once we install the SeeSharp tools, right? So here we can start our program, and here I'm using a Visual Studio Community version 2019. So you might be use 2015 as well. So it's without the same. Also, you're able to support. Yeah, let me open it. Visual Studio 2019. So take a second. In here, so let's just create a new project. And from here, right, yeah, take a second for it to be load. And from here, we're going to use a Windows Form app. And you can see few options. Windows Form app for for C Sharp, and Windows Forms app for VB, and the one that we're going to choose is Windows Forms app .NET framework. So please choose the right one. And click on next. In here, right? So just simply put a Jytek example one. You can name it any kind of name that you prefer. Yeah, in here just put an example one. So create it. Again, take a few seconds. Okay, so here you can see the front panel. Okay, so I already insert the C# tools, but let me show you guys. I'm going to delete it. Okay, so you can see by default they have a few tools, WPF, data, and by default by the Visual Studio. So in here, I'm going to right click any place and add a tab here. I'm going to name it as a Jytek instrument. You can name it any name that you want as well, so it's not fixed. So right click it, choose item, and from here I click a browse, and again C#, Jytek, C# tools that we have installed just now, bin, and in here we're going to choose C# tools JY DLL. So make sure to get the right one, open it, and then take a few seconds for you to load it. Okay, then click OK. So you can see we have our from here Jytek instrument. We have our toolkit, our GUI. So you have a EG chart, we have an array, we have a LED, we have a LED matrix, pressure gauge. So in here we're going to use the EG chart here. So let me put an EG chart here. Okay, so from the property side, right, so you can adjust the color or maybe the graph. You need to have a blue one based on your result or maybe your test requirement. You can just change it. You can monitor it anytime. So from here, I'm going to put an EG button here, the button that we start acquire our data. So I'm going to change it as a start. Start. Going to name it as a start. Okay, start. So let us start our programming first. Just show a simple programming. Okay, I'm going to right click so you can see our platform here. So the first thing you need to do, right? If you all remember, right? So just now we got install the hardware driver, right? So we need to install the hardware driver here. So I'm going to right click here, reference, and add a reference. So again, browse, C# again. So every C# toolkit or my platform you can go through C and C#. Jytek. So you choose hardware. So in here I got a DAQ and DSA. So let's say you have a switch, you have a RF, you have a DMM. So it might have a different folder showing. So in here I'm going to select the one that we have 2405, and I'm going to choose a bin, and ensure you choose the right one, the DLL file, not the test panel or maybe installer helper. So I'm going to edit. Then I'll press OK. So you can see here we got our reference point in here. So once we get ready, right? So we're going to use it using the USB 2406. Yes, 2405. Sorry. So in here, right? So I'm going to do a simple programming. EG button 1. So enable equal to false. So we set initially the button equal to false. Then I'm going to set double sample rate. Going to set the sample rate as by default. I'm going to set as maybe 10,000 and an integer. Sorry, integer. Okay, and sample to acquire. Let us acquire 1K sample. Okay, once we initialize all the things right, so we're going to initialize our device. So in here, AI task, CI, CO. So based on your requirement, right? Let's say in here we're going to use the AI task. Okay, AI task equal to new. We initialize it. USB AI task. We create a new simulation task in here. And once we do it all, so we're going to set our parameter. AI task dot add channel. We're going to have our channel O, or first channel connected to the sensor, and then we have AI task dot mode equal to AI mode dot. So in here you can choose either you want to have a continuous, finite, or single. So let's choose a single one, the simplest one. Okay, AI task dot sample rate. So sample rate we're going to use the one that we initialized just now. Equal to sample rate. AI task dot sample to acquire equal to sample to acquire again from the above. Close it. So once we set all the parameter right, so I'm going to start it. AI task dot start the program. So once we start it right, so we're going to record it. Double AI data. We're going to set the result as the AI data equal to new double pull the sample to acquire inside AI data, and AI task dot read data. We're going to read the data, AI data sample to acquire, -1, continuous. Okay, and then we're going to stop it after we acquire all the things so that we can record it. AI task dot stop. Okay, so once we start it, so we're going to show our chart, so our graph, e.g. chart dot plot. Going to plot all those data, AI data, into our graph. And then last but not least, we're going to get our easy button become a true. Once it's finished, enable equal to true. Okay, so that's all. So we got an error. Let me check. Okay, line number 34, AI task dot. Okay, in here, let me see again. Dot start. Okay, so okay, done. So let's try to run the program and see how it can be. Okay, so we have the graph here, and let's just start it. Okay, in here you can see we get a signal, right? So I will going to change, disable the auto scale and start it again. Okay, you can see here we got a signal, right? And I'm going to save as a CSV. Okay, in here maybe I'm going to save as maybe example one, right? Just now we have example one. Okay, so we can save the data. Actually, you can do it using our report generation toolkit as well. So in here, for example one, right, you can see the data, okay, from T and series one, the result that we have from what we acquire right now, right? Able to generate a report here, and also you can save the image as well, desktop, example one. Okay, so in here you can see we get the result. Okay. Okay, so just now we got a simple application using an AI task, right? So let me show you again. So how the C# able to do the capability of our C# open source platform, and what can we do in the report generation and get some array and a dynamic signal processor, something like that. So in here I got one example. So from here you can see the programming is built by Visual Studio. So just now you remember, right? You're able to recall. So I have a reference in here. I put a driver, install a driver, and I have an example using here. So beside of that, I also using some of the array and a file DSP. So we're going to create a file. So we're going to use a C# tools file and a DSP. We're going to have our signal processor. So the program is quite long. So you're going to generate some of the things. I write it, so I'm not going to demo it line by line because I think it might be not enough time. So just going to show you guys how you able to done. So from here, right, you can see again, I got the Jytek instrument, so a pointer and all those things. So we put in here our general user interface, our farm panel. So in here, I just run it. Show some demo, I run it. So I'm going to take left a little bit so you can see, so it didn't block you. So we got a setting here, we got a measurement, we got a file viewer. So first, we're going to go through the setting first, the board. In here, I set until board number 10. So we got the 10 board. So let's say you have more board for more machine condition, sound and vibration monitoring. You can set. You can just modify the program. Okay. So we are using a board number 0. So sample rate and 10K. So again, I'm going to change as what we did at the example. We're going to read only a 1K example. So channel 1, channel 2, channel 3, and channel 4. So we are using a channel 1 only. So accelerometer, you can choose either accelerometer, microphone, and maybe voltage. You want to get voltage, AI voltage, and IEPE going to put as on. So a coupling. So just now I got mentioned, right? Theoretical on the coupling on the offset related. So you can choose either based on your application. Scaling, we're going to choose one. So unit is MV per gram, or no, gram MV per G. Okay. So save data, we're going to enable it. So I'm going to save it as maybe I just put random name JY1 or maybe Jytek and Jytek 123. Just simple put a name. Okay, Jytek 123. So I got a save in the Jytek 123 demo. Okay, apply it. So in here, you can see we got RMS reading, we got the time. So here you got the alarm and the warning. So let's say you can set it. So let's say it reach how many. So you can set the alarm to be sound. Okay. So in here we're just going to start it. Let us start so you can see how is it going on. So I start it. So you can see the channel 1 they have RMS value in here. So the sensor is in static, so I didn't touch it. So you can see it got some noise, little bit, but it's by normal. So in here, let's say I touch it. Okay, I have some of the vibration in here. Okay, you can see I have a vibration. I shake it. So we have a vibration. You can see the graph start to be changed. So it be record the vibration in here, same as the time as well. So I have some vibration in here. I shake it and maybe I knock it. Okay, I knock it so you can see the graph change more obvious. Again, I let it in my table. It becomes static. So you can see it becomes stable again. The graph becomes static. Again, I start to shake it and I knock it. So it has some data. So once we get the data from maybe you want to measure the data from maybe 1 hour or maybe 10 hours, right? So in here I only measure 1 minute. So stop. So our time is 1 minute. So let's go to the file viewer. So I go into open back, and just now I said has a Jytek 123, right? So I'm going to open it. So it takes some time, maybe few seconds again to open the file. Let's just wait. Be patient. Okay. Okay, so here you see we get the data already. So in the beginning is zero noise or maybe zero vibration. In here you can see when I shake it, right, or maybe I knock it, so you can see there's some value. You can zoom it as well. There's some value in here, and you can zoom out as well. Okay, so you can monitor the time chart as well, and so I'm going to save the image, or maybe I want to have the image. I'm going to save it. Yeah. So open again. So let's say I want to open the previous one that I saved. Okay, maybe I saved last week, right? So I'm going to open it again, webinar. So it's not necessarily the one that you saved just now. So we can see I also have another type of data that I saved previously. So also I can zoom it. I can get the data in here. So I can zoom it again. I can zoom it again. Okay, I can see the waveform. How is it going on? Yeah, something like that. So that's all for me in sound vibration condition monitoring. So let's say you have any problem, right? You can reach out to us anytime. Yeah, feel free to contact us on Jytek, and can have our LinkedIn profile as well. Okay, thank you very much. Have a nice day.
Okay, Vincent. Next, we're going to talk about and share with you some application example done by some of our customers. So the first application example is in the area of machine condition monitoring diagnostic. So a lot of our clients are using data acquisition hardware from Jytek to perform vibration monitoring and also sensor measurements such as temperature. So this is actually coming from a client. They actually produce CNC tooling machines that has built-in IoT capability and also monitoring capability. So in most cases, during the machining or processing process, right, they need to monitor various parameters to make sure that the machine be operate as expected and there is no quality issues, right? By monitoring the vibration signal from the machine itself and also the temperature, they are able to prevent or predict failures and perform diagnostic on machines. So in this case, they're actually using our IoT Edge device, MCM6100, that's connected to USB DAQ. Basically, this is a multi-type or sensor measurement device that can measure thermocouples, thermistors, RTDs, strain gauges, voltage, current, and so forth. The next application I'm going to share with you is also for a inspection system. Basically, the customer have been using a very old system to perform the measurement. However, the measurement was done manually, so they need to automate the measurement, and they are using again MCM6100 with built-in sound vibration capability to measure the signal, in this case the peak value of the vibration, right, of the machine, and to make sure that they can detect any deterioration over time, right? When they use the machine to measure symptoms. The third application is also measuring both vibration and temperature, right? And this is actually for a engine test bed. Basically, this setup tests an car engine, right? That is again used in R&D, quality assurance, right? And so forth. So in this case, the test can run hours, days, or even weeks, right? So they need a system that will automatically collect the data, save into the database, and also report on any anomalies if something happens during the test. And their technicians are able to access the data through IoT dashboard using tablets or mobile phone, even though they are not at site, at the test site. The third application is again testing turbine engines and predict failures, right? So this is a high channel count application. So I believe the total number of channels it's measuring is about 120 channels, right? So they are using a lot of accelerometers to measure vibration that's mounted onto the chassis of the engine turbine, and using the massive data collected, it goes through deep learning, artificial intelligence, and they're able to predict the failures. So one of the result of the prediction is they come up with a RUL, or reliable useful life parameter, where it will predict not only failures of the engine itself, but it will predict up to days or in sometimes hours before the failure happens. So once the prediction is done, the technician can go in and further try to remove the engine from operation and use it and perform diagnostic on the engine itself. A lot of the high channel count applications is ideal for our PXI platform, where basically it's modular in architecture, and then you can expand up to 250 modules. For example, we have 8 channel sound and vibration analyzer module. You could have 250 of them, right, in a single PXI system, collect all the vibration data, and all the data is synchronized accurately for any phase measurement analysis that you need to do later. The next application example is actually from a ICE, or in-car entertainment maker. So they produce these ICE systems, right, to for the market. They initially they were using an old benchtop instrument to do the measurements. So they migrated to a PC-based system, industrial PC, with one of our hardware with PCI 969527, which they able to measure the quality output of the product that they are testing. So they are taking parameters such as signal to noise ratio, SINET, THD, total harmonic distortion, right, coming from the car audio system, right? And after the test is done, a report is generated. The next application is actually from a customer who operates a small hydroelectric power generators, right? In the country, right? So with small hydro power generation, it needs to use a lot of sensors, obviously, to monitor things like the flow, the pumps, the turbines, right? It continues to draw seawater, right? To power up the small hydro. In some cases, you can actually affect the environment, right? And again, if let's say there's any outage, a lot of things could happen, right? So using the data collected from temperature, flow, and pressure, it goes again into a processing algorithm, is able to come out with again reliable useful life of the pump, right? Such that technicians can predict and prevent failures from happening that can be catastrophic, right, for the environment. The next application is actually coming from a customer who owns a facility, right? Basically, it's similar to what I've talked about, right? But again, there's this new term called PHM, or prognostic health management. So again, as human beings, when we get sick, we go to a doctor, and the doctor would take readings, right? Our heart rate, blood pressure, and things like that. This is PHM is the same thing, but for machines and assets. So using sensors and data acquisition, we actually will monitor all the parameters, right? Similar to what you find in a human being, and using those parameters to perform prognostic. Uh, Previously, the customer was using instruments, handheld instruments, and then they have to send technicians all over the place in this facility to take down the readings manually, right? So in such an environment such as, again, it's raining, right, or under the hot sun, right? It's not so suitable to have, technicians go around minutes or even seconds to collect the data frequently. So in this application, we recommended customer to use the MCM 6100 again. And again, the MCM 610 actually can add in a mini PCI card, right? In this case, we added in a LTE module. So this whole system is installed at site, outdoor, right? And it's connected to various sensors to collect the data, right? And the data is being sent to the cloud. So using the data, they can perform the PHM, right, to look at anomalies and also predict any failures, right, to the system. The next application, again, for for factory facility. So basically, we're doing Industry 4.0 or smart factory type of applications, right? In this case, it's doing similar monitoring for vibration, temperature, pressure, and what is additional on this application, they actually are using Microsoft HoloLens. So the data is being collected through the DAQ system, sent to the cloud, and the HoloLens picks up the data and overlays the measurements and reading. So as a technician goes through the factory itself using the HoloLens, all right, the data or prediction of the machine failures is overlaid onto the HoloLens itself. So the technician can pinpoint accurately uh, where is the trouble spots, right? And using the HoloLens, they can bring up virtual manuals, right? That sort of like augment the capability of the technician to fix, right, certain parameters, right, or to fix the machine itself at the site. The next application is again sound measurement application. So we have a manufacturer of motors, right? So previously they have a very crude way of testing these motors. As the motor comes up the line, they will turn on the motor, and on operator will hear the motor sound, right? So based on the operator experience, certain sounds can tell the operator that okay, this motor is good or there's something wrong with this motor, right? However, with the human way of hearing, again, a lot of errors can occur. For example, if let's say the technician had a bad day, right, argue with the wife the night before, right, he might not have so perceptive sense of sound or hearing, right? Maybe the wife shout too loud to his ear, right? So again, a lot of errors could happen. So in this case, we recommend our customer to replace the operator or the technician with a IEPE microphone or so-called electronic ear that will mimic the hearing from a human ear, right? So the data is being collected over the MCM 610, and again, they are using machine learning and AI-based inspection, right, system that will accurately identify sounds. So first they will record the sounds of a good model, and then record samples of bad models, and using AI to differentiate between the different type of sounds and to come out with the result. So today we only cover collecting data from sensors, right? So if you think of it, a camera is also a sensor. So coming from AD-Link, they have actually smart cameras. Basically, it's the sensor array that you normally find in smartphones, right, or cameras, right, embedded together with the processor in one unit. So what happens is that it will take an image of any object, right? For example, you can take image of analog gauges, dials, digital meters, and perform recognition, right? So in some cases, for machines or sensors does not have electrical output, this is a way to overcome that limitation. So we also have another solution where you could actually connect, right, sort of like intelligent IoT device or gateway. Again, this product is called the DAQ 100. It will collect to the operator output. So in some machines, you have a OPC, maybe it's running DOS, maybe running Windows 3.1. It will output a operator interface. So this DX 100 will extract the operator interface output from the proprietary or old machine, perform OCR, optical character recognition, and convert them into a report, a text file, or write to the database. This text 100 also can mimic keyboard and mouse clicks, right? So this device connected to a proprietary machine can be operated remotely, right, over the cloud, right? So this mimics the operator clicking on the keyboard and mouse to control going through multiple screens, and it will also capture all the parameters in this. So this in a way typical industry 4.0 applications where they retrofit an old system, add additional intelligence and extract data uh, as part of the IoT, big data process. So to get a lot this data, right, into the cloud, normally you would use what I call the IoT edge or gateway, right? In most cases, our clients would connect to our data acquisition devices. So other than USB, Ethernet, we also provide PCI or plug-in cards. So the first device over here is actually a industrial gateway, IoT gateway that has expansion slots to put in your PCI or PCIe DAC cards. We also have USB and Ethernet ports, right, to connect to external DAC devices, right? And you can run Jytek SeeSharp, right, or other type of software platform in here, right? It runs the latest Intel i7, i5 processors, so it's a very powerful processing platform. Again, if you don't need such powerful processing, you can go with a smaller system, which is the E13900, all right, IoT gateway based on this Intel Atom interface. Again, it does not have a PCI slot, but it has a mini PCI slot. So you can plug in mini PCI modules and USB DAC cards, not only for data acquisition, but for image acquisition, machine vision, and also motion control applications. If you need a very AI-centric system, there's also industrial AI gateway from AD-Link as well. It's based on NVIDIA Jetson Xavier platform, where you can connect the DAC that is collecting data from sensors through this gateway, perform all the analytics, right, at the edge, right? And again, you can use it to control and talk to other type of industrial devices like PLCs, RTUs, and other subsystems. So depending on your project and applications, again, if you need to set up maybe 10, 20 systems, you can actually use off-the-shelf devices and gateway that we have presented. For some customers who are looking at OEM or ODM design, right? So we also work with a partner to do ODM design. Mainly, you can use our off-the-shelf data acquisition products and off-the-shelf gateway for prototyping your project. And let's say you need to deploy 100 or maybe 200 or even 1,000 systems, right? You need to cost the system down. So what we offer from Jytek is we also carry a SOM or system on module. So basically these are very small, tiny embedded systems, right? running Ubuntu, Linux, Android, Windows, right, for your application, right? So depending on your processing need, how rugged that you want, right, you can use this SOM as part of your end product or end design, right? So we have also starter kits for you to do what I call AIoT prototyping, where basically you can do similar and come up with similar solutions and products according to your specific needs. So in the ASEAN region, we're actually partnering with a company that can design the carrier board for you. So the SOM itself only contains the CPU, digital IOs, and memory. Next, we have Mr. Padma, who will talk about his design services.
Good afternoon, everyone. My name is Mo Padma. Today, I'm representing Promosys Technology, presenting to you IoT-based data acquisition hardware for edge processing. Okay, before we continue, let me briefly explain to you about Promosys Technology. Established in 2004, we are kind of a 17 years old plus company focusing in design and development, manufacturing of highly vertical process monitoring system. So in this context, when I say highly vertical, means products that is premium products, low volumes, robust, used in for many years. So we have products like we installed in 2006, which is still until now it's still operating. Of course, it's using SMS technology. We have about 35 engineering staff focusing on research, design, and development located in our Subang facility. In Subang, we call it our Product Development Center, PDC. We are a service provider, so we kind of provide our service to design and develop products for our customer, and we also have a low volume manufacturing facility, so we can do prototype and in-house low volume manufacturing so our customers, so products that need to be manufactured like 500 pieces a month or 1,000 pieces a year. Okay, we do it in-house so we can control supply chain and quality and performance and reliability of the system internally within our facility, so our customer can get total security. We are an ISO 9001 certified company. We also both our product development center and also our production facility in Klang. So as I mentioned earlier, we offer the blue circle of our, that is our expertise, our forte. So we do the research and development of new technologies. We learn about Sigfox, LoRa, NB-IoT, 5G, and other things, and we do the qualification processes of the vendors, module suppliers, chip suppliers, the kind of things. We learn about new things like CAN bus 29-bit addressing. So we learn about that first before we go to we offer that technology to our client, and also we do the development of software and hardware to meet our client and needs. When I say software, means firmware, programming tools, configuration softwares, and now in IoT realm, we do cover Android application, iOS application, and also cloud softwares. So we do manufacturing. We focus on low volume manufacturing. So anything that goes above low volume in our metrics, we have our EMS partners both in Malaysia and also in Shenzhen. So we can link it them up, and then our customer can manufacture there and continue to produce their boards. We can support them after that transfer of manufacturing to them. So basically, the customer is their product, their brand, and they have to invest on their marketing, exhibition, marketing material. So this is the orange circle is our customer circle, the blue circle is our circle. So our motto is your market, your product, we design and manufacture. Now let us go into our today's subject matter. I'm briefly going to explain to you about IoT a bit and edge processing. I guess I don't want to go into detail too much about IoT. I'm very sure all the audience here knows what IoT and what's edge processing, but just to bring the tune, I'm going to briefly explain about IoT and the need of edge processing. So IoT is basically collecting data from various sensors installed in various places and bring it to a central location and to create value. That's it, create value using sensor data. Now, in order to keep the IoT sensors cheaper, longer battery life, The design must be simple. The device must collect data and send to a cloud using low power wide area network connectivity like LoRa, like Wi-Fi, like Bluetooth, these kind of things. And then the cloud part where the data comes to a central processing location, it will be processed. It won't be done in the sensor itself, to keep it lower and simpler. Now, when I talk about edge processing, means rather than sending the data to the cloud, the data will be sent to an edge processor, a box, a gateway, a hub. A lot of people call it with a different name. So this is installed in between the cloud and the sensor networks, which collects the sensor data and does the pre-processing of the data, and also packaging it, added security, and sent to multiple endpoints to be processed later. So this is what the edge processing about. And I'll be slightly explaining to you 3 major edge processing solutions that we have expertise about in the next few slides. So here, a simple edge processing device architecture. So basically, it will have a central processing core. In this example, I'm showing a sodium-based system on module carrier board, which you will have a wireless sensor network on the downstream, and uplink connection can be a 4G, LAN, or Wi-Fi. Sensory input and output can be digital input and digital output, analog input, analog output, this kind of things. And there will be power management. There will be secondary power management for backup and either like solar or other kind of things. So in this example, we have done for a local customer, which consists of quite a high-end processing solution using a sodium 200-pin carrier card using a IMX 2025 core chip. It's an ARM9 chip. This is done for an industrial machine where they will install this edge processor into a plant where to collect data from various machines and machine parameters, process it in the plant itself, and then route it back to the cloud application which the customer have managed. So this one I can't show detail about the IO logics that we use because we have a strong NDA with our customer, but this is a basic architecture that internally I have. And then the final product is an aluminum casing, which is a good ventilation for heat dissipation and that kind of things, designed to work in a very heavy very highly dusty and vibration environment. So you stop this device in a corner, it works there for years to come. Okay, this is another example that we did for a customer in Malaysia. Also, this is used in Malaysia and also in Singapore, kind of edge processing, but for image analytical. So we have 2 sets of a solution that we have developed for our customer. One is for the parking operator, where they want to do number plate recognition and open barrier gate and charge e-wallet based on number plate recognition. So for that, we use Jetson Nano from NVIDIA, which is entry-level image processing solution. The second solution that we built on the same architecture design is using Xavier module from NVIDIA. Also, it's like Jetson Nano's ×3 or ×5 powerful capability, CUDA performance compared to Jetson. So this is used in a greenhouse installation where they want to monitor the growth and the color, the texture of the vegetation that our customer is using. So these are the example of image processing, which is done at edge. Image is not sent to the cloud. Image is processed, image is analyzed locally, and then the resultant snapshot image or the resultant data is being sent to the cloud. So this is another very good example of edge processing, which we used router modules. So routers are chips that route data from Wi-Fi LAN to another uplink. So with the with the availability of OpenWRT platform and also the modules that available, especially from company like Qualcomm, Cypress, or Realtek, we able to do this kind of products where it provide a Wi-Fi connectivity for the downstream application, like anything that can connect to downstream on Wi-Fi, and also it can provide uplink connection to the standard 3G, 4G, uplink LAN, or the kind of things. But before the data has been sent out, the data can be locally processed, locally managed, and locally analyzed, consolidated, and sent to the cloud. Now, this module is from a company called 8Devices. So sodium-based modules are a lot in the market. Jytek also having a lot of modules which we can use to build the products of your choice. So we came to an end of our presentation. So my presentation. So if anything you to be contacted, or if there's any further questions, you can ask me. My email address is there, and I'll be glad to answer. I'll stand by now.